Let us look at another parameter which is very importantly used to evaluate the accuracy of a linear regression model, and this parameter is called adjusted R-square. So what is adjusted R-square? Why is it useful? We have already seen what multiple R-square is. So multiple R-square we have seen in details. We have discussed how to calculate multiple R-square and what is the interpretation of multiple R-square. Now multiple R-square has one disadvantage. The disadvantage is that even if you add variables which are not useful to the model, multiple R-square tends to increase. So multiple R-square tends to increase even if you add variables which are not helping the model. Even if we add unimportant variables to the model. So which is bad, because in that case we will never know which variables are helping our model and which variables are not helping our model. Which is why we have another parameter called adjusted R-square. Now adjusted R-square penalizes the model if it is not helping, or penalizes the value of R-square. It penalizes the value of multiple R-square if you add any variable which is not helping the model. So if we add any variable into our model and if the variable doesn't help the model, then the value of adjusted R-square will decrease, it will not increase. Multiple R-square on the other hand always tends to increase even if you add unimportant variables to your model. So that is a disadvantage of multiple R-square, and hence we always rely on adjusted R-square while doing multiple linear regression. Now to prove this, let me go to R. I will take the previous example and I will try to prove that adding unimportant variables into your model leads to an increase in the value of multiple R-square, whereas adjusted R-square will decrease if you add variables which are not important. So to prove this fact, let me add some random variables into our previous data set, the data set that we have been using. So I will add some random variables into my data set. So I will use the rnorm function and I will generate 23 values. Remember, our data set has 23 rows. So I will generate a new column, an entirely new column, and the values in this column will come from a normal distribution. So rnorm function gives you values from a normal distribution with the mean of 0 and the standard deviation of 1. So this is how I'm generating random numbers and creating a new column into my data frame. So let me do this. Now if I show you my data, it looks like this. I have 4 columns now, the 2 independent variables that we previously had, 1 dependent variable actual, and I have added a third or fourth column x3 here, which has values taken from a normal distribution with mean of 0 and standard deviation of 1. Now I will try to include this into my model and see if it is increasing my value of R-square. Please note that this variable is totally random. I have just created this variable randomly. Now I'll run a model by including x3 as well. So let us run this and look at the summary of the new model that is created. So what do we see now? We see that the R-square has increased from 0.833. Remember, without x3 the value of multiple R-square was 0.833. So if the moment we included the variable x3, which is totally random, our R-square increased from 0.833 to 0.8394. But look at the value of adjusted R-square. The adjusted R-square has decreased to 0.814. Let us see the values of R-square and adjusted R-square in the previous model that we built without the variable x3. So without the variable x3, the model is linreg. So we see that the value of R-square is 0.833 and 0.816. Now let us look at the values in the model with the random variable. So it is 0.8394 and 0.814. So if we look at the values, R-square has increased by addition of the random variable, but the adjusted R square has decreased from 0.816 to 0.814. So this tells us that multiple R square may increase if we add unimportant variables. So this increased to 0.8394, a small increase though. So this is for multiple R square, and for adjusted R square we have, previously it was 0.8165 and now it has decreased to 0.814 on adding a random variable. So this proves that multiple R square tends to increase, whereas adjusted R square will not increase. In fact, it will reduce, it will decrease if you add variables which are not important to your model. So hence it is important for us to use adjusted R square to evaluate the accuracy of a linear regression model and not use multiple R square.